Hello, this is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on regression and correlation, and we're using some alien data here. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos, and this is part 2 of this set on this PowerPoint. And we are in the middle of example 1, where we have some male alien data, and we're making a scatter plot, finding the linear regression equation, making a scatter plot with the regression line, and using the regression equation to predict the weight of a male alien that is 4.5 feet tall, and we're going to show all of our work. In part 1, we made the scatter plot of the data, so here is the screenshot of the scatter plot from the TI-83 calculator, and we have labeled the axis with the height in feet and the weight in pounds, and that is the scatter plot of the data. So we are now ready to begin this video by looking at finding the linear regression equation. Notice the directions here. The answer to part B will be an equation. So we need an answer that starts out y equals something. So we need an equation. To start this process, remember we've done part 1 and we've put in the height into list 1 and the weight into list 2. So we have data in our calculator. If you've not watched part 1 of this series, you'll need to at least stop and put the height into list 1, the numbers for the height into list 1, the numbers for the weight into list 2 before you proceed. Then you will press Stat and then over to Calculate. And this is where I'll do some magic in my editing and fix some things here, because on the TI-83 calculator, that will bring up the linear regression. And then you will type in list 1, then a comma, list 2, then a comma, and then we'll want to type in the Y1. To find Y1, we will go and press the key vars, then arrow over to Y-vars, and then function. Putting Y1 at the end tells the calculator to put the equation in Y equals, so you don't have to type it in by hand. This stores the equation so we don't have to type it ourselves, and stores it. And this is the way older TI-83s and 84s work to get that screen in. On the newer ones that have submenus, you will press Stat, then over to Calculate, and you will, excuse me, I didn't do that right when I'm talking myself through this. You'll press Stat, over to Calculate, and then number 4, which is your linear regression, and you'll get a menu or a screenshot that looks similar to this. As you do that, you will notice you have a place to type in what your X list is, which is list 1. That's where we stored our height in feet and those numbers. And then our Y list, which is our weight in pounds, where we stored that was list 2. Then we have a frequency. We should leave that blank. And where we stored the regression equation, which is the Y1. And again, to find Y1, we press vars, Y-vars, choose function, and then select Y1. And that's where we store the Y1. Then we press Calculate and then Enter. That should then, again, it's the same, putting it in Y1 at the end, tells the calculator to put the equation in Y equals, so we don't have to type it in by hand. On the older versions, you will need to press Enter once you've got the screen to the left. On the newer versions, you enter on the word Calculate. And then you get this screen, or a screenshot that looks like this, and that's the linear regression. And it gives us the answers. It gives us y equals ax plus b, the a, the b, the r squared, and the r. Remember that we're asked to find the linear regression equation, which means we need y equals ax plus b. So we will write y equals ax plus b, and that gives us y equals 5.7009x plus 64.5452. Mrs. Borlaug rounds to 4 places. Be sure that you follow your teacher's rounding rules for how many places to round this to. Where does the a come from? Well, the a is given, and the a, y equals ax plus b, is given, and we rounded that to 5.7009. The b is at the end, and it comes again from the screenshot at 64.5452. And we have our linear regression equation. And the linear regression equation is complete. Now, just remember that x represents the height and y represents the weight. Now to part C, to make the scatter plot with the regression line. Since Mrs. Borlaug shows you how to store the y1 in as part of finding the regression line, all we have to do to get the scatter plot with the line is to press the word graph. It should now graph that line through our scattered plot. Again, remembering that our height in feet is our x-axis, our horizontal axis, and the weight in pounds is our vertical axis, our y-axis. And we can see that we have a strong linear relationship by looking at the graph. The scatter plot of the data with the regression line. Normally at this point we would test with the critical value to see if it was a linear relationship using not only the linear trend but the critical value. But that is not asked in this particular example, so we will go on to part D, which just asks us to use the regression equation to predict the weight of a male alien that is 4.5 feet tall, and to show all of our work. Remember from part B, finding the regression equation, that y equals 5.7009x plus 64.5452. The y is the weight in pounds and x is the height in feet, and we have this stored in our TI-83 or 84 calculator in y1. We have two ways that we can use our calculator to calculate the weight in pounds. We can use the calculator just to do the arithmetic for us and plug 4.5 feet in for the x. 4.5 feet tall is the height and x is the height. So if we plug 4.5 in for x, we need to find y by taking 5.7009 times 4.5 plus 64.5452. And this is how you would type it in the calculator. Notice that it will wrap around, and that gives you 90.19925, which we will round to 90.2 pounds. Again, rounding here to the same number of decimal places our original data is. Again, follow your teacher's rounding rules. I'm following Mrs. Borlaug's rounding rules. Now, this completes one method of finding the y, of using the regression equation to make predictions. Since it is stored in y equals in equation y1, we can use a shortcut method. And this is how we would type it in on the calculator. We would go to the vars, over to vars, then over to y variables, and then choose function, and then the y1, and then put parentheses and type in a number. And in this case, we would type in 4.5, then close the parentheses and press enter. Notice we get 90.199469493. It is a little bit different in the decimal, but it's accurate out to a couple of decimal places. And That's basically substituting 4.5 in place of the x. If we use this notation on the calculator does those substitutions for us and gives us the result. And we are accurate out to this. We are accurate out to 3 decimal places. Or the same, we're the same out to 3 decimal places in both forms, and when we round to 1 decimal place, we're the same. So either method is okay to use to make our predictions using the regression line. At this point, it's time to stop, and when we pick up, we'll talk about some things that can go wrong in this process.